Good morning, Geometry iPad Initiative students. This is Mr. Lane talking about Section 4.6, triangle congruence. Corresponding parts of congruent triangles are congruent. What this allows us to do is once we have triangles congruent, we can say that any part of them that we have would be congruent by CPCTC. So make sure you write down the section title and number 5. You'll make sure you answer number 5 in your notes, and also be looking for that secret word throughout today's lesson. So let's get rolling here. The first thing here is the CPCTC. What does it stand for? Corresponding parts of congruent triangles are congruent. And down here we have a very important note that we must have triangles congruent in order to use this. So we must have a triangle congruence statement before we can ever use CPCTC. So you might make sure you put something about that in your notes also. Now we have an example here that we get going on. We are supposed to state that AB would be 18 miles here on this one. Let's see how we could possibly do that. So notice that we got the 10 miles and the 10 miles here, so this would be congruent with this. We got the 15 miles, which would be congruent to the 15 miles, and then we got vertical angles, so the two triangles would be congruent by side, angle, side, because it's a side with the included angle and then another side. So the triangle, or sorry, the angle within the two sides is the included angle. So we'd have that the triangles are congruent by SAS, and then that would mean that the AB would be congruent with 18 miles, this last side of the triangle. So therefore that has to be 18 miles. Okay. Regular geometry students would be doing 2.7 from page 262 at this time. We're going to roll on here. It looks like we've got a little proof that we have to do. So I'm just going to draw a little 2-column proof real quick here. Looks like these should be congruent symbols in here. So my plan is going to be to show that these two triangles are congruent, and then from there I can pick out the parts that I need congruent. So I'm going to start with just the given, as pretty much always. We're going to put segment YW bisects segment XZ. I'm going to also just go ahead and list that XY is congruent to YZ. And that's going to be the given information. As always, I always pretty much start off with that given information. Now, 2. I think before I do 2, I'm going to go ahead and mark what's congruent in the diagram here. So we have this is congruent to this. We have that this bisects this bottom segment. Well, if it bisects that bottom segment, that's going to mean that segment XW is congruent to segment WZ. That's going to be the definition of bisector, or definition of segment bisector. Okay. So I'm going to go ahead and mark that now. Right there. Now, it looks to me like they share this common side, so we've practiced on this about 100 times. That's going to be the reflexive property, so that's going to be my step 3, is that segment YW is congruent to segment YW. And like I say, that's the reflexive property of congruence. So number 4 is we've got all 3 sides now marked congruent, so it's going to be side, 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 and we're going to say that triangle XYW is congruent to triangle ZYW. And then once we have that the triangles are themselves congruent, then we can say that any parts of those triangles are congruent. And that's what the new thing is from today's lesson. It's that CPCTC. So right here, we'd go right into that spot then. And that would be our proof. So regular geometry students would be doing those problems. We're going to roll on here. We got another proof. So let's get a little 2-column again. And you could do a paragraph proof, and you could do a flowchart proof. I just usually do the 2-column. But like I say, it doesn't matter. If you want to try one of the other proofs, feel free, knock yourself out. So I'm starting with the given again. I'm going to mark that in my diagram so I can see it. So we got these two lines are parallel. We just marked that with a little arrow. And then we got that N is congruent to P. Alright, so that's our markings. It looks like I've got a transversal here. I think I'm going to go ahead and say next that this angle is going to be congruent with, I'm going to say that this angle is congruent with this angle next. And do you recognize what type of angles those are? Those should be alternate interior angles. And I'm going to state that angle NOM is congruent to angle PMO. Alright, now I see that they share a common side right here. So again, we're going to use the reflexive property. Seems like we've used it in every single proof so far of congruence. And we're going to state that segment MO is congruent to segment MO. So it looks like I've got angle, side to state that the two triangles are congruent because it's the non-included side, so it's got to be angle, side. And we're going to state that triangle MNO is congruent to triangle OPM. Now once we have the triangles marked congruent, we can use this new thing that we just learned, the CPCTC, to state, oops, those aren't parts though. We need to state that these last two angles that I started to mark earlier are congruent. So we're going to mark that MOP is congruent to angle NMO. And if these two are congruent, then these two lines would have to be congruent or parallel. And to prove lines parallel, we have to use the converse of those angles. So those are alternate interior angles again. So we're going to state that our reason is the converse of the alternate interior angles. Okay, let's move on. Very good. Alright, we're going to end the video here for today. The secret word will actually be in the next video, so be paying attention for that when it comes out. This is Mr. Lane signing off from OHS High School. Catch you next time.